Good morning. Can you hear me? Hello.
Yes, good morning. Hello.
Okay, that's fine. As usual, in a minute I will switch off my camera and I will leave you only with the desktop slides. And during today's lecture, I will focus on a new subject that was already presented during the laboratory assignments in one group. However, before starting the next labs by the next groups, I'm going to explain a bit more about what aspects are, how they can be implemented, what they are used for. So let me switch off the camera. The connection will be more stable without that video stream. And let me start the lecture. So what is the aspect-oriented programming? This is how to say a new paradigm, or maybe old paradigm. Okay, this is the old paradigm of looking at the programs from the point of view of how to say the responsibilities or the subjects or the domain of interest that are so-called cross-cutting concerns. You met already during your implementation the need of printing out on a screen some debug informations. So usually this necessity comes in the places which you want to observe. For example, there is a specific execution call or function call, you want to monitor the results, or there is a specific assignment in your source code and you want to check whether this assignment is correct. And if you want to monitor such parts of your code, usually you do at first system out println, so you print out on the screen some debug information. If you are a more advanced user, probably you use kind of logging, so the classes or the libraries that you can attach to your project in order to collect the debug information inside log files, inside the files with comments which are collected during the execution of your program. However, such kind of the cross-cutting concerns might be much wider. For example, you would like to assign some security protections. So maybe when entering a particular part of your code, you should ask the user to insert his or her login and a password. And maybe in your code, there are also such parts which should be adjusted. You are not satisfied, for example, with the outputs of your methods. Probably you want to convert, for example, currency from dollars to euro or vice versa, but your methods deliver only one kind of the output. So without modifying this method, without modifying these classes, it's possible to attach a new logic to this part of your source of your application using just aspects. So let me show in this slide the idea. So if you have a method inside your code, so probably if you want to change the behavior of that method or you want to react on its call, probably you would like to put something in front of your execution code and after your execution code. So instead of placing these actions before your business logic, after your business logic, it would be nice to have the mechanism which would be used in such a way that you declare additional method, and this method will capture the point in which original method is placed. And before entering this original method, you would like you could do some additional actions. You could print out something on the screen, and after the execution, you could print also something on the screen, while the original execution would be done just in between these two parts. So these kind of the methods which can cover and protect the entry to the method you want to execute is called an advice. And in general, the concept of implementing these kinds of the logic is called aspect programming. The aspect programming in general allows the programmer to modularize application, so to collect this logic which is common to many parts of your original system. These parts can be separated from the others and can be implemented as a separate feature. This approach also follows a single responsibility. So this is a design pattern in which the classes that are implemented should have only one reason to be modified. So single responsibility is also a kind of the design pattern which is used quite often in programming, because it simplifies the structure, and it's the classes written with using that concepts are easier to modify than when using the a general approach. So in general, this kind of the additional acts in your code that will act before and after execution of your observed code can be done or can be implemented, introduced inside your system by various means. This part of the business logic can be injected inside bytecode or can be implemented using proxy classes. So this is quite important and might be even difficult part of aspect-oriented programming, because this is a very technical part. Depending on which approach you will use, so the configuration of your system and the possibility that are opened to you may be varying. So let me explain at first what it means attaching proxy classes. On my web page, you'll find out on the lecture subsection some links. So please go through these links and try to read the information which are there. And one of these materials has such diagrams. So if you have the class which implements a particular interface with two methods in it, with foo and a bar, so normally if you write the Java class, it looks like that. Okay, this is the class with two methods which implements a predefined interface. So usually when you call the methods on that object, you just run the call against that method, and your calling code will retrieve the response from that method, and that's it. So the diagram that shows the control flow is pretty simple. Your calling code just calls the method of the plain object, and the result of that object is returned back to your calling code. However, if you are running the proxy, the matters changes. Instead of just creating the objects and calling it methods, the scenario is changing. So using proxy means that instead of calling the method of your target object, you create a proxy, an object that runs as a facade to your target object. So there is even an API in Java that allows you to build such proxies. So there is a proxy factory which can be created, passing to it the object which should be covered by that proxy, that should be handled by that proxy. So having that, okay, if the proxy factory is created, we say that that object inside the proxy factory will be accessed by that proxy through that kind of the interface that is also assigned to that factory. Okay, so now we know that our proxy will manage the simple POJO object, and the access to the method of this object should be done through the predefined interface. And if we want to add some advices, it means some algorithms that will run before calling the original method or after calling the original method of this target object, you can inject this advice just by add advice method. So having created the factory and having set this factory up with these classes, you can ask the factory to deliver you a proxy. Please look what the get proxy delivers. It delivers object. This is in Java the basic class of all the other classes. But we know that that proxy will offer us a POJO interface. Therefore, we map or we cast that response from the get proxy method through POJO class, through POJO interface. So now we have the POJO, and POJO has a foo method, and we can call that method just like before POJO foo. However, this object now, which we are working on, is not an original object, but this is the proxy. And the proxy just gets the call and passes this call through the advices and finally to the plain object. Then the plain, this original plain object will run that method, and the output of that method will be captured by the proxy, and the proxy will return the control to the calling code with the value retrieved from that method call. So this is how it works. Proxies are like facades to the original part of your code that should be monitored. Especially this is true for the methods of objects. So this is what is the meaning of these proxies. So in general, this attaching proxies classes that intercept a method call and can execute the things before and after method call can be done also in two different ways. In many frameworks, there are two approaches to that problem. So one approach is to use something that is called CG-lib, and the other is using dynamic proxies in JDK. I hope that I have here some other examples. Let me check. No, somewhere in between these links, maybe here, let me check. There should be a chart showing the differences between these two approaches. So what is the CG-lib? So let me show this on the example. When you
sorry, we can only see the presentation on the screen.
Oh, okay. Thank you for reminding me. Okay, so I should. Okay, and can you see it now?
Yes, now we can.
Yes, you can.
Yes.
Okay, so at the I presented the slides, but now I switched the browser and I am showing the examples here. Okay, so what we have here. Oh, this is what I didn't show you these diagrams. Okay, can you see it now? Right. So I talk a few minutes about these slides, not showing them. Right. So shortly, I have the class which implements interface, and normally when I call that class, I am creating the object and I am calling its method. However, the same scenario can be modified or enriched with the use of the proxies. So instead of calling directly the method of the object, I can call the method of the proxy, and before that method, some additional business logic will be called, and after that again, and finally the plain object will return the value and the proxy will return the call for the calling code. So normally it is done, this kind of the approach can be done through the proxy factory. So I create here the new simple Podger object, which is the attribute by which I set up this factory, and I set up that factory with the interface that should be offered by the object of this factory, returned by these factories, and I also inject the business logic that should be run as a device to the method calls of this interface, and finally I am asking the factory to deliver me a proxy, and this proxy for sure implements Podger interface, so I can call the foo method from that interface on the object returned from the factory. So difference between the first approach and the second is that in first approach, this is what normally is done in your code. So you create object and you call method on this object. And the second approach is a bit different. You call the methods of your objects, but not directly, but through the proxy object. That object will pass the calls to the original object because they are injected into the factory, and will return the responses or return value from the methods. However, before and after the proxy can run a device which is injected like here. So is it clear now? I'm sorry that I did not observe that I am not presenting you the right slide. All right, so this is the proxy. However, this kind of the proxies, as I said, can be implemented by mainly by two means. And there is a CG-lib, the library that allows you to play with these proxies. So if you want to play directly with this CG code generation library, and if you are running a Maven project, you can add additional dependencies, and you can have a class with some methods, and you can create the proxy to that class. So there is a enhancer. This enhancer is how to say, is injected with the superclass, and it also creates a callback, and there is a proxy, and you can run the method on that proxy and say hello, and that method will return always hello Tom as the response, right? Because this is the fixed value method. It will not take any arguments. It will return always hello Tom. So that way, this is very similar to the schema I presented a minute ago. You can enhance your code and through the proxy. Of course, if you want to get some more business logic in it, you can run this library using method interceptor. You can retrieve the return values from the methods, and so on and so on. This is the so-called API, right? This is the library that allows you to do a lot of things, but you must familiarize yourself with this library in order to play with these proxies. So what is important is that this kind of the proxies, after using, they will be compiled into the bytecode. So in general, the name of this library, code generation library, means something. It means that the additional methods, additional proxies will be compiled inside your code. There is also another framework, which is JDK proxies, Java Dynamic Proxies. There are some other articles mentioned here. You can go through and read the details. In general, it is quite similar. Let's say the proxy is a proxy, right? However, the declaration of the proxy is a bit different. So let me show. Here we have the class dynamic invocation handler, which implements a given interface. So it has an invoke method. Okay, and here is another part of the code. There is a proxy which creates which has the factory method new proxy instance, and here we assign to that proxy instance the class loader and the class and the instance of that class in order to get the proxy, which later will be used to put some value in it. So as you may see, inside that proxy factory method, we have also assigned the class loader. So not going into details, let me explain that this kind of the programming is heavily dependent on so-called reflection. It's possible inside the Java bytecode to extract the information about this bytecode. So it's possible in your application to check whether a particular class has a particular method. You can load classes which were not known to the compiler during the building of your system. And even that you can run, you can discover what kind of the method this class offers, and you can call this method as well. So I already told you that this kind of the mechanisms are used, for example, by the framework which uses the annotations. Annotations are also embedded inside the bytecode, and the different frameworks like Spring Boot, like Hibernate, discover these annotations through reflections and deliver some business logic which depends on the values delivered by annotations. So this is how it can be implemented using the JDK Java dynamic proxies. These are two different approaches. CGLib, it is said that the proxy delivered by the CGLib are faster than dynamic proxies which are delivered with the use of the framework Java dynamic proxies, because these are just compiled into the code, and you run the classes which are compiled, and here you could create the objects dynamically, and this object then pass the method calls to the proper object which are injected inside these proxies. So this is a bit different approach. However, I am not asking you to learn in details both libraries, both approaches. I will switch to how to say, to the aspect-oriented programming, which just does a magic, right? It covers all the details of the implementation of these proxies behind the scene. So the programmer does not need to bother about the details of these proxies. It just uses what is offered, some annotations, some language structures, and the rest is done through configuration. However, please remember at that moment that when you're running aspect-oriented programming, in fact, you must decide whether you are working by injecting code or whether you are working with proxy classes. And if you are working with proxy classes, which framework your system must use in order to deliver these proxy classes. It will be clarified in a minute when we set up our programs. So, summarizing the aspect-oriented approach, there are few concepts that you need to understand. So, aspect is just a modularization of a concern that cuts across multiple classes. So this is something like logging, like security, like tests, like other kind of the concerns that can be attached to all your classes or to selected classes in your source code. This is not a, how to say, these concerns are not like a class structure. These concerns like are sitting aside your class structures, and they can be attached to your classes on different level of derivation or on different level of interface implementation. So in Spring aspect-oriented programming, the classes aspects are implemented using regular classes, or these classes are annotated with aspect annotation, and some of the configuration can be also done or can be implemented using aspect-J annotations. I will show you now the example to explain what is the difference between these two approaches, between implementing a regular class or the class which is annotated with aspect annotation. What is the join point? Join point is the point inside your source code in which you can inject or plug in your aspect. So this is like, how to say, the definition of parts of your source code in the execution path, which should be enriched with aspects. A device is just a business logic which can be attached to your source code around joint point, but in fact it can be attached around, before, or after that joint point. And point cut is like a template. This template can be used to select the parts of your program under which you will attach the aspects. So it's, how to say, maybe quite difficult to understand from the definition what it is, but the example should clarify the matters. So let me show the simple flavor aspect J, the source code of the application I prepared to you, and I exposed this application on my web page. You can find it on simple two flavors aspect J zip in this archive. So what we have here, I have a class which looks very simple. This class is named A, and it has get and set methods which are used to set the value and retrieve the value from the counter, which is a private member variable and private field, and that's it, nothing more, just a simple main. And inside that main I am creating the object, I am setting the counter, I am retrieving the counter, and I print out that counter on the screen. It seems quite easy program. I can compile it and I can run that class. So let me say that this class is already compiled, and I am going to the source code of that class. Simple, where it was, two flavors. Okay, here, and I have the source code of that class inside that folder. So to be perfectly sure that I am working with a just compiled class, I can compile it. I can compile it using Java 11 or Java 17 compiler. So let me compile that class with JDK Java 11. So C, because my JDK is on a specific path, so let me go to the to this path. In bin I have Java compiler, and I will compile that class. Okay. So as you may see, okay, this class has been compiled just a minute ago, 9:05. Oh, just now. The date of my class is and the hours shows up that this is correct, just compiled class. So let me go a level above. I am in the root of my compiled classes, and I will run that class using JDK Java 11. So Java minus class path here, because I will start from the root, and my class was in the package module, so I am calling that class with the fully qualified name, which includes its package, and models. So this is the package. All right, and the response is 10, as expected. My class was declared to print out on the screen the value which was set by the set method, and it is exactly what I expected. However, I can change the behavior of that class without modifying this part of my source code. I can do this in the following way. I can declare an aspect. And this is a class which is annotated with an aspect annotation. As you may see, the code inside that file I am presenting now is just the Java code, nothing strange. The only part which is maybe tricky are these parts with annotations. Okay, so I have an aspect annotation in front of my aspect annotated class, and this class has additional method which has an empty content, does not take any arguments and does not deliver any values. And this so-called method is annotated with a point cat. So in fact, I declare something that should match the execution of any get method inside my A class, which comes from the models package. So this star I am highlighting now. Can you see what is highlighted? Right?
Yes.
Yes, okay. So here is a say that I am interested in any get method. After that get keyword, it can be any other string, and that method which I am interested in might take any arguments. This two dots means any arguments. In general, the syntax of that point cat is declared in the aspect J specification. Okay, so this is a specific language in which you declare what you are interested in. So I am interested in execution of get method, which takes any attributes and returns any value. Okay, and I name this is like a pattern, and the point in which this pattern will be detected, this is a point cat get. Okay, so now I am declaring the advices. Advices, so business logic that will be run in my source code once the control flow will reach this point cat get. So as you may see here, I have the before annotation and point cat get, which is attributes given to that before annotation. These two must match the name of the empty method with the name of this attribute inside the before annotation. So having that, I declare the method, but the signature of this method is very specific. Okay, I have here the joint point. The attribute which is inside that joint point is a joint point type. This joint point represents me the place in my code in which this pattern was applied. So somewhere in my code, I will run this business logic, and the joint point can be used to identify in which point my control really is. Okay, so this joint point has some methods, because this is an API used by Aspect J. Okay, this is from Aspect J framework. It has a get signature. So if my joint point is around some method, and if I want to check out which method really was captured, so I can get signature method. I can call get signature method, and toString, it will print out the signature of the method. I will know after that which get method joint points, and you will see in a minute how it works. So I have also after returning. So this is maybe more interesting advice, because this advice will be run after the method call. After get will be executed, my business logic will be also executed. This is like this the proxy method, which will be run after the original method of the object which was observed. Okay, so but here I have something more in my after returning annotation. I have returning value with the counter attribute assigned to it. So what it means, whenever your method you are looking at is a method that returns the value, so you can capture that return value, naming it in a returning attribute of your annotation. And the same name should be in your signature of a device after method. Here we have again join point, and here we have the counter, and this counter, it will be, as I said, the value that will be returned from the function that you were observing. So in fact, this after returning advice will run correctly on the get method that returns integers. If your get method that you are looking at returns some other values, so this after returning advice will not work correctly. All right, so I have the device, and this advice again prints the signature of the method and the kind, and also the value that was retrieved from that method. As you may see, you can intercept the return value, and you can do something after returning that method. You can modify the business logic of your program. All right, so this is the aspect. Similar thing can be expressed using extension of Java language. Here is that extension. You can declare, as it was just a few minutes ago, so let me show. This was an aspect annotated class, and here I have just aspect class. This is a class, but this class is enriched or is predicted by the aspect keyword. As you may see, my environment recognizes these aspects, this point count, and this before keywords. These keywords are recognized because I am using an additional plugin to my environment. This plugin is called AspectJ. So if you want to set up your Spring tool suite in the same way as I did, so let download version 4.10 of this STS tool. Okay, the newest version for 16 does not work well with that plugin. So what I am running Spring tool suite number 4.10, and it can be downloaded from that web page. Okay. And afterwards, I installed from the marketplace additional plugin. This plugin is called AspectJ. So let me show that it is working. Okay, now my system just scan all the repositories, and AspectJ, if I search for it, so I will see there is AspectJ development tools. So this is already installed. If you want to install, you will on your environment, you for the first time you will have the install button, not installed, but install. So I am not installing it again. What this Aspect J tool or plugin does to your environment? It can it delivers you additional view or workspace. You can see your classes in additional perspective, but I will return to that. It offers you these markers, as you may see. Once you run the Aspect J project, inside your environment, you will see which methods are covered by which aspects, which is quite interesting. You can see that some of your methods of your original class are already captured or covered by the implementation of your aspects. So I can see them that really this get counter method is already covered by my aspect which was implemented here. But I have also Aspect J files. Can you see the extension of this source code is .aj. So it means that that source code is a Java, however, enriched with additional keywords and constructs, and this construct and keywords are specified for Aspect J. I have again here a point cut. This is the name of this point cut, and this point cut now takes the argument, and this point cut will be assigned to the every set method of the A class. Moreover, because I am working on the methods that might take some arguments, so I can also declare what kind of arguments I am interested in. So this syntax might be complicated. During the labs, you will not use that syntax at all. However, I wanted to make a full description of the Aspect J technology. Therefore, I am referring also to that extension. Okay, so here is the point cut, and here is the advice. The advice does some business logic, and this advice is before this point cut, which was declared on every set method of A class, and it will handle the counter attributes, which will be passed to the set method, and after that the rest is very similar as it was previously. I am printing that I am before the method. I will print out the kind of the method, and I will also print the attributes with which that method was called. And afterwards, as you may see, my syntax highlighter just highlights some parts which were recognized, so it's not working very well. Sometimes this highlighting comes later. This after is also a keyword, should be printed in a color, but it is not, but doesn't matter. It is working. So I have the after advice, which will run after the getting to the defined point cut. So let's check how it works. So now I will run this application, but I will run it through the interface. So I will run this as a run as Java application or Aspect J Java application. Okay. So after that, see, I have this 10 number, which is printed by my print method inside my A class. However, I have before, after, before, after. This is what delivered to me my aspects. My aspects inform me that they executed before entering the set counter method, and this method was called with the use of the 10 with the value of 10, and after set method my aspect just printed out that it was there, and before entering the get method I was informed that I am entering that method, and after calling the get method I print out that the get returned the 10 value. So exactly what I declared in aspect definitions, right? So summarizing this simple example, I have the class and I have aspects. One aspect was using annotations, and the other was declared using aspect J. In fact, when I run this project, this is aspect J project, you can see that every project in Eclipse environment has a nature, where it is, and the nature of this project is a Java project and aspect J project. If you want to assign to your project another nature, so you can select the different natures from here. You can, for example, modify this project to be a Maven project. Depending on the nature of that project, the ID behaves differently. So if the project is aspect J nature, then the environment displays the content of the aspect AJ class files. Sorry, it displays the content of the AJ files using the, how to say, the editor that understand the extension of the language. Moreover, such projects are compiled using, and especially this AJ classes are compiled using aspect J compiler, which is additional, not Java, but aspect J compiler, additional compiler that is delivered together with that plugin. That compiler compiles in aspects to the bytecode of your class. So let's see how the bytecode of my class now, how it looks like. So to check out what is the content of my class, this is the content after the compilation of my original class. My models.a class has a constructor, has a get and set method, and has a main method. I decompiled the bytecode, okay? But now I will try to decompile the class which was compiled by aspect J compiler. So I will change the directory into bin, because there are classes that were compiled by my IDE, and now I will display the content of my okay. Something strange. Well, let me check again. Okay, I will modify something here. I will modify something here. Okay, and I will run this as a even Java class. Okay, it is working. So the compiled class should be in the bin directory, and here, and the class, okay, it was just compiled seconds ago. So we run Java P in the bin directory. Okay, -p. All right. So I forget about this -p, which also discover the content of the private member variables. So let me show you how it was in the source, in the class that was compiled without aspects. So this is the difference. Can you see it? Okay. Here is the content of the class that was compiled without aspects. The class has a private member variable counter, constructor, get, set, and void method. However, the class that was compiled by the aspect-j compiler now has some more fields. It has a private static AJC TJP0. Can you see? And it has a static initialization part with curly braces, and it has a static AJC pre-c init method also inside the class. What I want to say is that aspect-j compiler just waived aspects inside the bytecode of my A class. This is not original bytecode. Now this bytecode of my A class has been changed. My source code is without any modification. The source code of my A class is as it was at the beginning. However, the bytecode of my class now includes additional static private fields and static private methods. These methods are just the methods and fields necessary to attach the devices to my class before get and set counter methods. So this is quite tricky, and it goes on a very low level, on the bytecode level. So the normal programmers and students does not even know that such things appeared. However, I want you to understand that what we done here is that we use aspect-j compiler that waived in during the compile time the aspects into my classes. And if there would be more than one class with get and set methods inside my bytecode, so every class would be treated in the same way. So I can attach here a new class, and I can name this class as a B. And okay. And I can create and I will assign to that class get and set methods. All right. And now I have two classes in my project, and I will change the will it work? Let me see. So any class with get method will be inside the package, should be processed. So I modified this, and the class B should be modified as well. So let's try to run the project. Nothing changed. However, the class B was with the get methods, and A was with the get methods. So let's check whether the aspects were waved into the A class. Yes, they were. And let's check whether the aspects were waved into B class. Yes, they were. Can you see? Both classes were modified. To the both classes, these aspects were injected. However, the class B has less aspects than class A, because what I modified only the join point of which was declared for the get method. So the get method will be observed for any class in my models package, while the set method is only for the A class. So therefore, the aspects in the B class does not cover the calls to the set methods. Okay, so as you may see, I have a business logic which is declared and put aside the original code, and these aspects can be assigned to classes whenever they are in my source code. So therefore we call this a cross-cutting concepts, because they can lie aside. These aspects might not be placed in any of derivations tree. They can just lie aside and they can match selected classes in my source code. So this is quite nice and quite interesting approach to how to modify the existing source code just without entering any new lines in the source code, but placing aspects aside of the original sources. So at any moment I can remove these aspects from my source code, and my application will run as it was running originally, however, without the business logic which was declared in aspects. So let me come back to the presentation. So there are, as I said, target objects. So the aspects that should be advised, and I showed you these A and B classes. The instance of these classes were target objects, and AOP proxy, as I said, this is the object that allows us to play with the aspects, which allows to attach aspects to these target objects. And these proxies are used in Spring Boot framework by JDK dynamic proxy, or are implemented with JDK dynamic proxy or CG-lib proxies. It depends on the Spring Boot configuration which approach will be used. And waving is the approach by which these aspects really are linked to your target objects, and it can be done at compile time. So this is what I already shown you, that my classes after the compilation will be enriched with the aspects, and this is the compile time waving. However, it's also possible to attach the aspects during load time or during the runtime. So the differences are very, how to say, are not so easy to explain, because during the load time, it means that particular class loader which is used should load also the classes of aspects. When it is said that it is during the runtime, so it means that when the application starts, all these dependencies should be loaded as well. So this is, how to say, an advanced level. So I will skip it. I will show you in example how you can play with it in your projects. So there are different types of advices: before, after returning, after throwing. I did not show it, but it's possible also to declare the advice which will be called whenever an exception occurs in your code. There is also around, so which covers us before and after. And inside this around, you can call the advice method, or you can just reject the call of the advice method. And playing with Aspect-J in software with STS tool is, as I said, can be done with doing with the declaration of Aspect-J project and declaring the classes with these point cards and so on. And it can be also run as an Aspect-J application. This is what I already taught. And the aspects can be also declared with annotations. So they can be declared in language using this extension of the language, and they can be declared using annotations. So annotations are preferable by me, and annotations are used also in Spring Boot. Spring Boot does not support the fully Aspect-J programming. It supports its own, how to say, profile of aspects, and this profile requires the use of annotations. And the declaration of the point cards relates on declaring the business logic and the pattern which maps the places in your code that must be monitored. And there is the declaration of the expression, how to declare before, after returning, after throwing around is shown here. And there are links in my presentation in which you can discover more information about particular parts of Aspect-J programming. And there is this part, maybe I will show it just now. There is a cheat sheet web page, and on this cheat sheet web page, you will find out the, how to say, the description of what is the syntax of this expression that can be used to declare the point card. So you can declare it as a method designators, you can declare as type designators, because it's possible also to assign, for example, the point count to anything which is within a particular class. Not only methods, but every access to the field, every access to the constructor, the access to everything which is inside the class can be also monitored. However, many of these designators are not supported by the Spring Boot AOP. So I want you to understand also that if you are working with Spring Boot in general offers you something that is called aspect-oriented programming. It has a DAO support, it has a Maven MVC support, and other parts of the, how to say, concern and libraries supported, but it has also aspect-oriented programming support, and this support has some limitation regarding the original aspects. What can be declared here are the point cards and so on. However, the target, or the as it was the designators are only for method execution. So only this part of the how to say, the source code can be observed and can be handled with the use of AOP API, which is delivered in the Spring Boot. Okay, so this is what is written here, and there is a long tutorial you can read through, and you can check how you can annotate the methods, and how you can play with other joint points. But why so many words in regarding the aspects? Because during the labs, the coming lab, and one group already has passed the lab with the assignment which was related to aspect J. In general, during the labs, I will ask you to use aspects to enrich your existing web application. So let me show how I did it in my application, in my students app. In my students app, I declare additional package which is called aspects. Can you see, right?
Yes.
Yes. Inside that package, I declare my aspects. So using API of a Spring Boot, when I declare the aspect should be annotated as an aspect. Moreover, because we are working in a Spring Boot, I want to create a proxy object inside my Spring Boot application that will be kept during the lifetime of my application in a Spring Boot container. So I must annotate that class as a component. So the Spring Boot will know that it must create a singleton of that class inside the container. So what this aspect is doing? The aspect should run around this point cut. As you may see, now I have a shortened notion. Before, in my source code, there was a point cut, and after that there was an advice. So let me switch back again to this to flavors. So here I had the point cut, and then I had the advice, which had the definition of the point cut inside it. But now it's possible, which is presented in my configuration or in my declaration of my aspect, just put already this template inside around advice. Do you understand? It's possible to declare point cuts as a separate part of your implementation, and then use this declared point cuts inside declaration of the advices, right? But you can put directly this pattern inside your annotation which precede your advice. So this is what I did in my implementation. I have around, and without definition of the point cut, I am just using the pattern. So what I am interested in, I am interested in capturing the execution of the method of any method of the student class. Can you see? Any method of the student class which takes any attributes and returns any value will be monitored by my around aspect. Then around advice. What this advice does? Here we have the proceeding point, which will tell me where I am. Okay, so here I am printing the class which I am working with. So I will know on which type my aspect has been declared. And I also print out the signature of the method, because I don't know, I declared that I want that aspect to capture any kind of the method call, but now having the get signature and get name possibility, I can check which method exactly has been called. And now I have the inside a proceed method. Do you remember what proceed method means? The proceed method means that I want to call the original method on my target object. So my proxy must call the original method, and the return value of the method can be captured as the response of the proceed method. So this return value is of object type, because the framework was done or was prepared in that way that proceed method will call the original method on the target object regardless the kind or the type of the output value, because anything in Java which is a reference can be assigned to the object reference, because it is a base class of classes. Of course, to interpret this value correctly, so I would need to know the signature of the method and the return time of that method. So how to interpret, how to cast that object to proper value, it depends on which method was really captured by the advice. So you should, if you want to use that code inside your application, you should check on the method signature, and based on it, you should do the if or switch you should put inside your method, and depending on the signature, you should cast this object to the proper value if you want to use that value for some reasons. And after that aspect just return value, because this around will be called instead of the original method, and in fact the return value should be returned to the place where the system was running. So the return value should be returned, or you can just skip this. You can return null if you want to reject the execution of that method at all. So it's possible, as you may see, quite easy. It's possible to change the behavior of the system without modifying original code. So this is my aspect. Simple aspect around. This is nothing strange. This is quite simple to understand. However, the biggest troubles here will come when you try to bind all these things together. So first, you should deliver the configuration to your application in which you specify which library will be used by your framework in order to deliver these proxies. So I specify here that I am enabling load time waiving. So aspect j waiving enabled will be set in the variable aspect j waiving. So you can read what it means in the description of API, but if you want to, to go smoothly through the lab, you can just repeat my settings in your code and it should work. And enable aspect j auto proxy is set to proxy target class with a true value. So this, in fact, specify that your aspect proxies will be implemented using Java dynamic proxies. If I don't mix it. Anyway, this is something that can just select which kind of the proxies your application should use. Enable Spring configured is for setting up that this also is related to the Spring configuration, and component scan is needed in order to check which part of your project should be covered by that aspects. So because I'm working on aspects because I'm working on classes which are in aspects package, so I say that my configuration should be attached or should be used on the classes inside these packages and also inside the model, because in fact what I want to observe is are the instances of the student class which are declared in the model package. So this component scan was designed here. And what else? This aspect config is a bean, and this bean is created by the myLogin aspect method, and this method will just deliver this proxy object, aspect of, and my class, and this proxy object will be delivered and will be a singleton in your application, right? So this is what is needed in order to have an aspect existing in your runtime. So this application is also okay. This is not the only setup which I put in my application. I have also a main class inside which I declare some additional features. So I declare here that my application should use JAutoProxy. Okay, so don't forget also about this annotation. And here again, I have component scan, and I declare here aspects also to be scanned in order to retrieve the annotations which are in the source code. And the rest is, how to say, unchanged. So this is all. I declared aspects package with config and aspect implementation, and I modify a bit the annotations in my Spring Boot application. And the last thing is which should be set is in a POM, okay? Because I am using AspectJ libraries, so I would need to also attach some additional dependencies. And these dependencies are somewhere here. So starter AOP, AspectJ runtime, AspectJ Weaver, Spring Instrument, and okay, the test is not necessary. Okay, these three dependencies, starter, runtime, and Weaver, are needed in order to make this application running, right? So the Maven will attach these dependencies to your project, and I have also additional remark to you. In order to run that application, do you remember this application will use load time waiving? It means that the aspects will be not waved into the code after the compilation, but these aspects should be created dynamically. This proxy objects should be created by the environment. So to give a chance of my application to create this object, I must deliver the proper agent to my application. There is -Java agent attribute in which you should declare some dependencies. So as you see, these two attributes should be put into the line by which you run your application. So let me show you the configuration. And my student as aspect-J configuration is such that I have in my arguments this Java agent dependencies, right? So this M2 repository, org, Spring Framework, and so on, and Java instrument 5.3.1, and the second part with I have aspect-J Weaver 1.9.6 jar. These are references to the libraries which are downloaded by the Maven, because in my POM I have some dependencies to the aspect Weaver. Okay, so in my dependencies in the POM I have some aspect Weaver dependencies. Therefore, my it was at the very bottom. So I have these dependencies, and this is already 1.9.6 version. So in my Maven directories, I will have this jar already present. My Maven will download it. And however, to run your application, because what you have here is only for compilation purpose, but to run your application, I have no plugin that will run my application with configuration inside Maven. I run this as a Spring Boot application. Therefore, in my configuration of the run, I assign the arguments to virtual machine, showing that virtual machine where to look for particular proxies, for particular Weaver. So this is it. And now I can run this application as a Spring Boot application. Okay, where it was run configuration. So I can, I want to run that one, Spring Boot with the arguments, run, and my application starts. My application, as you may see, at the very beginning displays some comments. If you have these comments in the system log, it means that your Spring Boot application really started correctly, and this aspect-J weaving has took place. So I can see that really this Java agent aspect-J weaver really started 1.9.6 as it was declared, and this aspect starts with some configuration, and it register my aspect. It just deliver me the instance of my aspect, which will be running inside my proxy. All right, and then I have again the displaying that the Weaver started, the classes are registered, and I can see that joint points were waved in, so they were already detected. Every method of the student class has been covered. So for every call to that method, I have the proxy inside my environment. This is what I expected. And after, I have joint points on the method execution. So every method, student method, even this hash code and compare and toString, every method will be captured by my aspect. So maybe my aspect was, how to say, too broad. Maybe I should limit the number of methods which are covered by the aspect, specifying in a bit different way my joint point. But anyway, I am not worried now. I am wanting to show you that these aspects are working. So let's go to the local host 8080 and the student app. and index HTML. So this is my view to my students app. Okay, this view, in order to display the content of my database, has already called the service method, which in next step called the repository method, and they extract the students from my repositories, right? And as you may see on the output of my log, in the logs of my application, I can see this Hibernate has been displayed, because in my configuration I said that my application should display all the SQL requests on in the logs. And I have also this entering, leaving, entering, leaving, entering, leaving, many times. Why? Because during my execution, my controller, where it was, there is an API, and API controller. So my view just ran the get method. My get method, where it is, let me check in that way. Okay, my get method, in fact, was the method which calls find all students. And in this method, find all students, there was a request to the repository to find all the students. And after that, my students class was filled in with the objects which were retrieved from that repository. However, every call to the find all students method create a new entity which was inserted in the list. So every time that new student has been called or was created, his get roll number, get name, and get surname method was called. Therefore, I can see the logs which are displaying me the information that my control flow just was entering and leaving proper get methods. This is what I implemented in my aspect, right? I wanted to print out on the screen that every time I call any method of my student, I will print out that I am entering to this method and I am leaving to this method. Because at first I only displayed all the students' data on the screen, so the get method of these entities were called, and this is what I've seen. If I try to edit a proper student and I want to change its names and save changes, okay, so you will see that on my screen, okay, there are set methods calls as well. So as you may see, these set methods are, how to say, after set of the number of the set methods, again there are get methods, and again set methods and get methods. Why? Because telling the truth, my view works in that way that it creates a new object, it sets its method, and after sending to the repository, it retrieves the students again and run the get methods to display the content on the screen. So there are several set and get methods called, and I can see in the logs exactly the order in which these methods were called. All right, so this is what I wanted to show you. The aspects are, how to say, quite interesting concepts in the programming, and they offer you a possibility of, how to say, attaching business logic without modifying existing classes. And there is a comparison and of an explanation of different point cuts, wavings, and so on. You have a list of tutorials and links, a list of links to the tutorials which explain exactly how to play with this aspect J and dependency injection and so on. Maybe a good point is also to study tutorials which are or sample files which are offered on the GitHub on the Spring Boot, and this application are here, or the examples are here. I loaded them to my environment as a Maven project. I modified a bit the POM just to cover only these parts which are related to Spring AOP. And what I have here, so let me show, this is the very end of my lecture, some examples. Okay, I have a service which is a class that has a serve method, nothing strange. Class which is a component, a Spring Boot component, just a class. However, the class has a method which is annotated with log execution time annotation. This annotation is also nothing, it's not very special. It is an annotation that can be assigned to the methods, and it was declared inside the same package. So class and annotation is just simple thing. And I have the aspect. This aspect is declared as an aspect and component. Okay, so I will use Spring Boot aspect-oriented programming. And what I say here, I have the advice, which is declared as errand advice on every part of my code, every method that is annotated with that log execution time annotation. Log execution time annotation, it's an annotation. So this is a very special kind of this pattern. If add annotation appears in the point cut, it means that I am interested in observing the execution of the methods which are annotated but by that kind of annotation. All right, so this is simple. Around is simple, and what this advice is used for? It just collects the time, current time under the execution of this advice. Then it runs the method which was observed and returns at the end the result of that method call. And in between, it collects again the current time and distracting the previous current time from that value. It will retrieve the information about how many milliseconds took the execution of this observed method. So this is like a tool to observe the time execution of the methods. Quite interesting. If you want to check how much time your methods will take without modifying the source code, you can just assign such aspects to your application. In general, aspects are not very, how to say, well suited to build a production-ready applications. Aspects mainly are used as the tools to control the execution, to run some tests. And in fact, this tutorial, Spring AOP tutorial with the examples, is just for that, for running tests. So here is the example of the test which will handle the execution of that aspects. So let's go to the tests, and Here is the test. The test is written using JUnit. And if you don't know that framework, so let me explain that its use is quite simple. You declare the classes usually, and the name of these classes are ended with the test keyword, and you can annotate that these are the tests classes run by Spring Boot test environment. Within Spring Boot test environment, you can create the bin inside here. If you declare the field which is annotated with AutoWire, it means that Spring Boot framework must inject the instance of the service inside that field after the execution, after creating that object. This service is just the base class which I implemented before. And here is the test, the method that should be run as a test. So what we call the serve method, nothing else. However, as you may see, this example is much broader. It has several other aspects already defined, and some of them are the aspects that should be attached to every call of every function. Therefore, when I run that test, we see that the execution will end, Spring Boot will start, and I have a lot of debug information. So this debug and so on are just done through other aspects which are in my source code. However, the last line inside that source code, which prints out void service serve executed in 2001 milliseconds, is the result of execution of my aspect. This aspect called the serve method, and monitor or check the time, how much time it took to execute that method. And as you may see, that method in general, its implementation was very simple. It was the execution of the sleep method for 2000 milliseconds. So entering and leaving that method took 1 millisecond, because the whole method took 200 milliseconds according to what was written here. All right, so this is the end of my lecture. I want you to understand that aspects are quite nice. Aspects are cross-cutting concepts. With use of the aspects, you can put a business logic aside of your existing classes, and you can waving this business logic into these classes. Okay, normally if you want to obtain the same effect, you should put in every line of the every observed method additional source code. You should modify every place you want to observe, but without bothering about where these places are, without searching for these places, you can just declare aspects which will be waved automatically in these places specified by the joint points. So to make it running, you need to set up your environment, and that's it. All right, so this is the end of my lecture. Any questions? Are there any questions? No? So I will stop my the sharing. Where it is? Okay. And during the labs, the next lab, I will ask you to implement the aspects that will enrich your application, that will collect some specific statistical data about your calls to your service. And please check how I implemented it in my project, and please check the tutorials on how to use aspects within Spring Boot application, and follow carefully all these dependencies and all these annotations, because the biggest trouble with using aspects is just to properly set up your environment, to properly declare the POM file, and to properly deliver the configuration to the Spring Boot application, and to deliver proper attributes when you start your virtual machine in a command line. If everything will be, how to say, correct, the task should be easy for you. However, if you do some mistakes in the configuration, it might take hours to figure out what is wrong. So be careful. Thank you for listening. I am inviting you to the labs and lectures which we will have in the next week. So see you then. Bye.
Bye. Thank you.
Goodbye.